Welcome back. Today we're diving into something exciting, symmetric difference. Well, the symmetric difference helps you figure out which elements belong to either set, but not to both. Let's take a look at an example with two sets, A and B. Set A contains 1, 2, and 3, while set B contains 3, 4, and 5. Here we want to find the elements in A or B, but not those shared between both. Elements 1 and 2 are in A but not in B, so they belong to the symmetric difference. Elements 4 and 5 are in B but not in A, so they also belong to the symmetric difference. However, element 3 is shared between A and B, so it's excluded from the symmetric difference. So the symmetric difference includes elements 1, 2, 4, and 5, but not 3. There's another way to represent symmetric difference. It's the union of A and B minus the intersection of A and B. Let's start with the union of A and B. This includes all elements that are in A, B, or both. Now let's visualize the intersection of A and B. These are the elements that are common to both A and B. Finally, let's highlight the symmetric difference, A delta B. These are the elements in A or B, but not in both. Symmetric difference can also be found using the formula A equals A minus B plus B minus A. To understand this, let's first highlight A minus B, which includes the elements that are in A but not in B. Next, we'll highlight B minus A, which contains the elements in B but not in A. Finally, the symmetric difference A delta B is the union of A minus B and B minus A. It includes elements that are in either set but not in both. Let's summarize what we've learned. The symmetric difference of two sets, A delta B, contains all the elements that are in either A or B, but not in both. One way to calculate the symmetric difference is by taking the union of A and B and subtracting their intersection. Another way is to take the elements in A that are not in B, add them to the elements in B that are not in A. So, symmetric difference is all about finding what's unique to each set.